Okay, so this is a video on the properties and attributes of polygons. So we have to first establish what is a polygon. Okay, a polygon is a figure that's constructed out of segments, and those segments have to be attached in such a way that each segment attaches to two others, and they have to attach at their endpoints. And if two segments are have a common endpoint, they cannot be collinear. So they actually have to move off that line and into another line. Okay, so we get different types of polygons. Some polygons are called convex. And the way we're going to define convexity here is that if you were to extend any side of that polygon, then the side does not cross through the interior of the polygon. Okay, but see, if we look here, like this side doesn't cross through the interior, that side doesn't, but this one right there crosses through the interior of the polygon when it is extended. So this polygon is convex. This polygon is non-convex. Sometimes the term concave is used to refer to non-convex polygons. It's an acceptable term, perfectly fine. We can go with that, but generally speaking, I'm going to use the terms convex and non-convex. Okay, so we're going to get this polygon angle sum theorem. So let's say I have a polygon that has n sides. Okay, we don't know how many sides it has, but it has n of them. So it's got to be at least 3, but we can be as many as we want. Then, and I take these angles, A1, A2, A3, out to AN. If I add up those angles, so if there's n sides, there's going to be n angles. The sum of those sides is n minus 2 times 180 for any convex polygon. So that is what we're going to call the polygon angle sum theorem. That the sum of the angles of a n-sided convex polygon is n minus 2 times 180. So like if it's a triangle, it's 3 minus 2 times 180, which is 1 times 180, which that lines up. That's 180. If it's a pentagon, it's 5 minus 2 times 180, which is 3 times 180. So let's see, 3 times 180. Let's see, that's 24, 3, 540 degrees, right? So this is how we can find the sum of the angles of a convex polygon. Now, proving this is a bit of an interesting reality. Okay, so the proof here uses something called an inductive proof. Okay, an inductive proof assumes that this works when n is equal to k. Okay, you have to prove that it works for some specific n. And then you also have to prove that the kth iteration leads inextricably to the k plus first iteration. Okay, so this is like kind of like dominoes falling. So if I have the original domino fall, don't know which number that is, but let's say it's the third domino, right? And I can show that the kth domino makes the k plus first domino fall, right? So the k plus first domino, I want that to make that one fall. So the third one is going to make the fourth one fall, the fourth one will make the fifth one fall, so forth and so on, out to infinity. So that means that every domino from the third one forward will have fallen if I have these three things. That I assume that the kth domino is going to fall. I know that it has fallen for some specific domino. In my example here, it could be the third, it could be the first, it could be the 19th, whatever. And then I have to prove that the kth version makes the k plus first one fall. If I have that, then I get everything from that initial domino forward falling infinitely. So I'm actually using induction to prove an infinite number of cases, which this is kind of cool. This is a pretty rare proof technique, but it's one that's excellent for the situation that we have here. Okay, so we're going to prove that this is true for n equals 3, right? So if we have n equals 3, we have a polygon which is a triangle. And we have three angles, A1, A2, A3. And we know that A1 plus A2 plus A3 should equal 180 because it's a triangle. And if I think about this, that's the same as 3 minus 2 times 180, which is 1 times 180. So this means that my theorem works for all triangles. Okay, so what do we have to do here? Well, we have to assume my theorem works for n equals k. All right, so this means that I have some k-sided polygon, right? And that this game is going to work for that k-sided polygon. So I have a sub 1, a sub 2, a sub 3. This one is a sub k. This one is a sub k minus 1, a sub k minus 2. And the argument that is if I add these up, a sub 1 plus a sub 2 plus a sub 3 out to a sub k, I should get k minus 2 times 180. Okay, so now I want to use this assumption and this fact to prove that this works, that we're going to get that this is going to work for n equals k plus 1. All right, so how do I prove that? Well, I have to add an extra side here. So what I'm going to do is I'm going to add that side here. So I'm taking away one side and I'm adding 2. Right? So let's call this I don't know, P, Q, R, right? So now my angle measures should add up from, let's see, the first angle is no longer A1, but it's A1 plus P. Then I get A2 plus A3 out to, let's see, this angle is now AK plus Q. And this angle up here is now R. So that's all of the angles of my polygon. Well, let's see. That's the same as A1 plus A2 plus A3 plus AK plus P plus Q plus R. All right, so this part is K minus 2 times 180. This part here is 180. So let's see, what do I get there? If I pull out the 180, I get K minus 2 plus 1 times 180. When I factor out the 180, switch the negative 2 and the 1, and this is going to give me K minus 1, or K plus 1, minus 2 times 180. So what have I just proven? I've proven that if I start with n equals k, then I can use that assumption to show that this works for n equals k plus 1. So I have the kth domino knocking over the k plus first domino. This shows me that the third domino is going to fall, n equals 3. This tells me that 3 makes 4 fall. 4 makes 5 fall out to k. K makes k plus 1 fall. K plus 1 makes k plus 2 fall out to infinity. Well, the minimum number of sides a polygon can have is 3. And it can always add more, but I have this going to an infinite number of sides. So now my theorem, n minus 2 times 180, works for any polygon with 3 or more sides, which means that it works for any convex polygon. So this is not a proof that you're going to need for a test or anything like that, but it's kind of interesting to note, and that it exists, and we can actually use an inductive method to get absolute certainty on an infinite number of set of cases. It's a rare thing in math, but it happens, and this is one of the places that it happens. All right, so we have one more theorem to look at. We're going to prove that one. It's pretty simple. Okay, so we have this thing that's called a polygon exterior angle sum theorem. And this thing seems kind of strange. It says that if I have a polygon and I extend each of the sides only once, so I extend this one way, extend that one way, extend that one way, extend that one way, extend that one way, and I take that angle, that angle, that angle, that angle, and that angle. So let's call that B1, B2, B3, out to BK. No matter how many sides this thing has, if I add up B1 plus B2 out to BK, the theorem says that these are always going to add up to 360 degrees. Always. If it's a triangle, the exterior angles add up to 360. If it's a quadrilateral, 360. Pentagon, 360. Hexagon, 360. Dodecagon, it doesn't matter. You get 360 degrees. Seems like it's a bit much. Okay, so let's think about this. Each of these angles is paired with an interior angle. B1 is paired with A1. B2 is paired with A2. B3 is paired with A3. BK is paired with AK. All right. We know a couple of things here. We know that A1 plus A2 plus out to AK has to equal K minus 2 times 180 by our last theorem. We also know that since each of these is extending out, then AI plus BI has to equal 180 for all I, which are from 1 to K. All right, so let's try to figure this out. A1 plus B1 plus A2 plus B2 out to AK plus BK has to equal, well, let's see, that's going to be 180 times K, because each of these has to equal 180, and there are K of them. All right, but I know that A1 plus A2 plus out to AK plus B1 plus B2 out to BK should then equal 180 times K. But this part says here that should equal K minus 2 times 180 plus the sum of all the exterior angles. Okay, so let's just subtract that from both sides. B1 plus B2 out to BK should equal 180 times K minus K minus 2 times 180. Let's see, if I distribute that 180 and that minus sign, I should get 180K minus 180K plus 360. These fall out. Tells me that B1 plus B2 to BK is equal to this, and this is equal to 360. So there's my proof. Alright, so a lot of work there, but that's how we get this, that the sum of the exterior angles of a polygon always adds up to 360. Okay, so two big theorems here. One is that if I have a polygon and I add up the interior angles, A1, A2, A3, out to AK, and the polygon is convex, this is going to be K minus 2 times K minus 2 times 180. And if I take the exterior angles, right, so the ones that are on the outside, so B1, B2, B3, out to BK. So B1 plus B2 plus B3 out to BK. That result has to just add up to 360 degrees, regardless of how many sides are in the polygon.